Now I would like to explain generic data types. And I want to show how to use them and what you can achieve with them. Therefore, I would like to use the class archive as an example. This class archive files something. For example, something what I will call content. So I pass something to the class that it has to file. And this will be filed within a variable called content. And to pass this to the class archive, we have the method store. The method store receives a content from a certain type and doesn't return anything. Now, if we would program this, we could think something like, what kind of data type do we want to file here? As an example, we could say, we want to file a string here. When using the method store, we would say, yeah, whatever we pass, this should be a string. Or we could say, no, we rather want to store integers there instead. Then we would pass integers to this function. Let's say we have many different data types we want to store in an archive. Then we get a huge amount of archive classes that all look exactly the same. The only difference between them is that they use different data types. Of course, that's something we don't want. One solution for this, which has been used before, is to say, then let's call that object. And everything that is going to be stored there has the type object. The reason for this is that in Java, every class is inherited from the class object. Therefore, everything is actually an object. Now, let's take a look at the disadvantages that result from this approach. I'm going to switch to Eclipse. I've already built a class here. This class called archive has exactly one member variable called mContent and a method called store. Furthermore, we have a method called emit to be able to read the content at the end. Below in the main method, we instantiate the archive. Something is going to be stored, and we see if we try to store an integer, it will fail because Eclipse says, hello there, this is no string. You said you only want to use the method store for a string. Let's take a closer look at what I said if we try to store integers. We would need to change it everywhere. At the method emit, we would expect an integer. Now, we have the ability to store integers. As we can see, there are no more errors. But, of course, Eclipse will say, yeah, but now you can't save strings anymore. It is important that Eclipse always tells us which data type we should store. And if we have an archive that is only for integers, then we should not be able to pass a string. And that is the problem if I change everything to object. We could do that so we don't need to construct 23,000 different archive classes with a single integer data type, a string data type, and so on. Now, we can insert anything here, but we can see that we are also able to insert integer objects along with string objects at the same time. That is something we don't want. We want that if we use an archive class, this class will be variable. So we should be able to insert only strings or integers. Now we have the ability to use only one archive class. And we can use it for everything, but for saving content it is not variable anymore. For this reason, they are generics. To use generics, we add angle brackets behind the class name. And in this brackets, we enter a generic data type. Let's call this T. In most cases it's called T, but you can use any other name. Now everything will be equipped with this data type T. That, however, still needs to be named. And in the description of the class, we have designed everything with T, but no one knows in the moment of constructing the class what T actually is. This information about what T is will not be announced before the instantiation. There it will be said, okay, here please use these angle brackets. Now we enter instead of T the data type our archive should use now to store the stuff. As an example, this would be a string. Now we can see that we have no problems passing the string here, but that integer objects basically are locked out. And if we say that we want an archive storing integers instead, we will just change it here. Now it will be possible to pass integers to the archive, but not strings anymore. This means we have exactly what we wanted. We can write an archive class performing a certain function that isn't restricted to the data type. So we don't have to write 23 versions of the class archive, one time for strings, one time for integers, one time for packets and whatever we need to implement. And we have the advantage that while instantiating the archive, we specify first what kind of data type this is. But from now on, everything else won't get accepted. For example, if we say, I would like to have an archive for integers, we can't pass strings to it anymore.